Module 3.8, Intro to Lab 3, Standing Waves in a String. In Lab 3, we're going to observe what we learned in the last module. First, that standing waves occur in strings. Second, they occur only at harmonic frequencies as defined by the formula F equals n over 2L times the square root of T over mu. Third, as tension increases, frequency also increases, but in a square root relationship. And finally, as length decreases, frequency increases. We'll use the following equipment: a stand, a string vibrator, a signal generator and cables, string, a pulley, a table clamp, a mass hanger, masses, 2 meter sticks, a 1 and 2 meter stick, and a scale. Before setting things up, you need to find the total length of the string and the mass of the string to determine the linear mass density of the string. Also, find the mass of the mass hanger. To set things up, clamp the pulley to the end of the desk. Place the stand on the laboratory bench about 1.5 meters away from the pulley. Put the string vibrator on the stand all the way to the bottom, with the words on the vibrator facing up towards the ceiling. Tie one end of the string to the hole on the metal tab of the vibrator. Tie a loop onto the other end of the string, connect the mass hanger to the loop end of the string, and hang it over the pulley. Finally, connect the red and black outputs on the front of the signal generator to the string vibrator. Set the frequency to 10 Hz and the voltage to 2.5 volts. For the first part of the lab, you're going to find the first 7 frequencies that create standing waves. Tune the frequency generator so the amplitude of the string is at a maximum for each frequency. For your initial measurement of L, make sure you measure from end node to end node. This will not be the same as the total length of the string, and the end node might not be at either the end of the string or at the vibrator piston. You'll have to look. Here's a huge time-saving tip. For your calculations, you'll find that some values are the same for different trials. For example, for the first set of wavelength calculations, 2L is constant. So find that number and then just divide it by n each time. Similarly, for the theoretical frequency column, calculate 1 over 2L times the square root of T over mu, and then multiply that number by n for each frequency. For part 2 of the lab, you will be using just the third harmonic and changing the tension. The first trial should give you the same results as n equals 3 in the first part. Then add 1 20-gram mass at a time for each of the next 4 trials. For part 3 of the lab, remove the 4 20-gram masses and leave the 50-gram mass. Your first measurement should again be the same as the results for n equals 3 for the first part. You're now going to move the stand and the vibrator 20 centimeters toward the pulley for the next 4 trials. Make sure that you measure L from the end node to end node. At some point, the mass will probably hit the floor. Just tie a knot in the string to make that end of the string shorter so the mass is above the floor again. Graphing help is in Blackboard in the Lab Write-Up Resources folder.